Okay. So hello and welcome. First of all, I'm very happy that we can meet in person this year. This is really something very refreshing after the difficult year of 2020. So I'm very glad to be able to be part of this awesome community here this year. And my name is Michal Buszkiewicz from Curiosum, and today I'm going to talk to you about a topic that has programmers divided by mindsets, preferred techniques, and many other factors, which is debugging applications. Sorry. Okay, and a few words about me, and I promise it's really a brief one. I am CTO and co-founder at Curiosum, a Poznań, Poland-based software house. This presentation is kind of a fruit of my entire journey in the Elixir language, which can be described as learner turned practitioner turned tinkerer, which kind of describes my attitude to programming pretty well in a nutshell. And I like doing weird and unorthodox stuff, and most of this presentation is going to be about stuff just like that. To start lightly, the first thing I'm going to touch on in my presentation is the attitudes people have when it comes to analyzing their apps' flaws and errors. And it seems that programmers' attitudes to debugging vary a lot from person to person, and these attitudes have a profound effect on developers' productivity. Stack Overflow, for example, is some people's first choice when it comes to finding out why their code is not working correctly. And while it's good to Google for ready solutions, you can't count on having it do all the job for you. Then when you get to be creative, some people won't bother setting up any real debugging tools, and as a habit they've learned over time, they will just print to the console to test stuff out. Sometimes it's just moving the print statement up the code until it's finally executed, which is like dipping a sonar in the sea. And at the other extreme, there are people like me who would rather hack every little thing and library they touch, even sometimes instead of reading the documentation. And as more often than not, code is poorly documented, I believe it's a justified approach, and I love working in environments that make it easier for me to literally pry into every little code corner, which is why I used to love Ruby back in the day, among other reasons, where I was able to modify every single already defined module or class and do whatever I wanted to analyze how it works. And I would sometimes do this even if it had a good documentation. With Elixir, I had to adapt. It's also a very flexible language that allows me to do a lot of hacks, but as it's functional at compiled, I've had to readjust my habits to its characteristics. And this is my favorite sort of mindset that I sometimes see in Elixir forums. People arguing that Elixir is as a highly concurrent language, doesn't need anything else than tracing and maybe IoInspect. So it's like, I don't need this, so you don't either. People assume that Elixir code is solely about pure functions, and that this alone should warrant impeccable quality of code. Surely enough not to need anything beyond observer and IO-inspecting. And in threads with questions on a specific debugging tool, these people, instead of answering the question, will promote the idea that Elixir is a language that by its nature doesn't need, well, needs little else than IO-inspect. And even more interesting is the assumption about naturally very quick code recompile and reload in Phoenix, and moving debugging lines around being no trouble. I've seen too many projects that had spaghetti dependencies to believe this. When you land in a project written in a way that involves compiling 100 files every time you make a little change due to module dependencies being poorly structured, you will quickly hate the idea of IO inspecting anything. So some takeaways from people's attitudes. You know, most apps are developed in a rushed way, and there is no real-life example of an app free from technical debt. So there is a saying that you should always try to write your code as something that's only incidentally interpreted by a machine. And the real recipient and reader is a future developer who's going to work on this project, and you never meet them. But you can't only rely on everyone else following this principle, so you won't escape having to master debugging techniques to an extent. And then relatively few commercial projects are really well documented, and even some well-adapted library creators stop doing any docs apart from the README. So this has taught me to trust actual code that I see way more than any accompanying docs. And overall, there is no single attitude cue to efficient debugging and getting to the bottom of something that goes wrong in your application. But being creative and inquisitive is something that kind of sums up well what I think about this. And I guess that's the key to being efficient at this. So anyway, some people will still insist that Elixir is a language that leads to good design choices, blah, blah, blah. And that's why you don't need to bother with debugging like you used to. So these people will still be saying this, and I won't be fighting. So now moving on to the tools and techniques available for Elixir programmers. The toolset is different depending on what issues have to be resolved. Different tools are using for analyzing and profiling a running system, which is very useful for getting to the bottom of whatever's going on in production. And a totally different story is digging into code flows while developing the application in a dev environment. So in Elixir applications, you can use everything Erlang has to offer. Its built-in tools, Observer and Debugger, as well as external tools for message and functional code tracing. So for live system debugging, we have the Erlang Observer, which is a must for large-scale production systems and allows you to pick into your Beam applications load, memory, OTP applications, processes, and so on, as well as tracing messages and function calls. The latter two can also be traced using more lightweight tools, more suitable for dev toolsets, such as Redbug, which is a tool that you can use in the console, as well as its Elixir syntax-friendly counterpart Rexbug. And Early which I don't like as much because it's got a Java-based GUI. And of course, for debugging anything running on Beam on a lines of code level, you can use Erlang's debugger to go through your code step by step when you need to see precisely what the current execution context is and find faulty lines of code. And this tool is also OK for Elixir usage with some reservations that I'm going to talk about later on. So in the Elixir world, in addition to all the tools that you know from the Erlang world, you can use Elixir's and related libraries' proprietary tools. For example, Phoenix Framework has the awesome Live Dashboard tool, which has quite some of the features known from Erlang Observer, as well as Phoenix-specific features like telemetry, integration, request login, and so on. Obviously, you can also use mechanisms to analyze the functioning of your application, such as the OpenTelemetry thing that Kamil talked about. But for the lines of code debugging, there is also the IEX's built-in pry and break features for inserting breakpoints in the code and interacting with particular execution contexts. In this presentation, debugging at the code level or the lines of code level is the thing I'm going to focus about. So let's assume that I'm mostly talking about all kind of breakpoint-driven debugging techniques that allow you to interact with a particular execution context at a specific place in the code. These are obviously techniques mostly restricted to development and test environments, but contrary to some opinions I've seen, it's not a good reason to neglect it and disregard its importance in the language's toolset. After all, it's often very practical to analyze the behavior of a code running on a single node that's intended to be parallelized later on. So in the end, you might have a preference towards debugging using GUI tools such as the Erlang debugger or some kind of debugger built in your IDE or code editor such as Visual Studio Code, which has a rather faulty Elixir debugger in my experience. Or just use the REPL to, like IEX to debug stuff. But the truth is that most GUI tools we've got either lack functionalities that we need or are clumsy in usage. So I usually seek for good and comprehensive tools that I can just control using the REPL. For those who like debugging by printing stuff into the console, Elixir has the IoInspect function that can be nicely plugged into a pipe operator expression. There is also the logger module for more complex logging, which will be inevitable for most large-scale applications to some extent. But the usage of logging and printing diagnostic information relies on you knowing exactly what to look for in a particular code context. And in your dev environment, it's just more often than not more practical to take a break, look at the current binding, play around with a function here and there, look up how data structures look like, and remember that you often can't rely on your predecessors and library creators doing a good job with type specs and documentation. So the Erlang debugger is really great for usage in Erlang itself, but rather clumsy for using it in Elixir because you don't really feel exactly at home with having to, if you want to evaluate an expression, you have to write it in the Erlang syntax, which is not very friendly when you just want to stay in the Elixir world. And it also requires starting it manually with the console and marking modules for interpretation each time you want to have a module debugged. So it doesn't really provide me with the comfort I was once used to with REPL-based debuggers in Ruby, etc. So here comes IEX, which was very disappointing to me when I had my first encounter with its debugging tools. There is the pry functionality, roughly corresponding to the one I know from Ruby, but well, this allows me to insert a breakpoint at a specific line of code by inserting the IEX pry macro call. But intentionally, it's not a fully featured debugger with which you can step into and out of functions and over particular lines of code and so on, step by step. So inserting line breakpoints with the macro is pretty simple, but always involves recompiling the code. So theoretically, it should be fast, but in poorly structured applications, which always have to be debugged in some way, it's just slow, and it's in most applications like that, it's just a pain. There's also a break helper, which is great because you can go into the REPL and, for example, insert a breakpoint separately for each arity clause of a function, or insert a breakpoint for functions defined outside of your application, which you, for example, have in your the library dependencies. So it's sometimes good to pick into a library code with this this helper. But this helper only inserts breakpoints at the very beginning of a function, and if the function in question is short enough, then it's okay. But as I said, it's not a perfect word, and sometimes we land into situations when a function we want to analyze is this long, and that's quite painful. When it comes to using IEX's debugging tools with Phoenix framework, or in fact any cowboy-backed library, timeout issues also come into play. Cowboy's default 60-second timeout on HTTP requests is very annoying by default. So it's quite good to increase it accordingly, at least for your development environment. The same thing goes to EXUnit's test case timeout, which I can only see being any good in headless setups like CI, for example. But in a local dev env, it's only annoying. Along with this, you can increase the database ownership timeout to avoid repo cases, lose DB access as you tinker with the breakpoints. Then, as we said, so how to use IEX like a pro? IEX is a very limited tool by design, and I acknowledge that, but there are some tweaks that the programmer can do on their own to tweak it with new features. And let's look at how to use some metaprogramming tricks and IEX's macros to conveniently peek into pipelines and navigate step by step through your code. All right. You can clearly, if you ever used IEX Pry, you can clearly remember that it's inconvenient with expressions that use the pipe operator. Because if you've got an expression like that and you want to pick into the intermediate result, you have to break that expression into two expressions, insert a breakpoint, or if you don't want to do this, you only have the IoInspect function. So, well, people usually go for using IoInspect in this case. But while this is okay in many cases, as I said, sometimes it's more appropriate to interact with that result in a way rather than just printing it. So initially, you can just slot in an anonymous function like this. And it's a rather ugly expression that gets formatted to a multi-line one with mixed format. So I thought, why not create a convenient macro that does the same thing? I can create a macro that gets transformed to an AST equivalent to piping in this anonymous function, and something that's often an alias will now serve well for us. Backtraces will remain in the line at which we insert the macro, or rather at which this macro expansion happens. So pry will not go into that anonymous function, so we won't see this thing in the backtrace or in the pry, well, IEX pry current location of code, but we will see the place where we use this macro actually. So to expose the argument to a context outside the macro body, we use the var thing to circumvent macro hygiene that would normally disallow us from seeing this variable in the current binding. So as you can see in this example, we can now insert this call into the pipe operator expression and interact with the intermediate result using the variable name of our choice. We had this as you saw here. So we kind of create this variable and inject this into the binding. And I guess it's pretty cool. So you can, this line gets highlighted and you can interact with the intermediate result quite easily. All right. Well, now let's move on to another issue that bugs me with IEX, namely we can't navigate to the next line of code. We can insert a breakpoint with pry or break to interact with the context, but we cannot navigate through the code like you do with proper debuggers. So I asked myself if I can overcome this without tampering with how IEX breakpoints work. And here's what I did in just a moment. To allow navigation between each consecutive pairs of lines of code. You can insert as many price statements as needed. So I thought, why not use a convenience macro to help me? And since def itself is a macro in kernel, and well, even def macro is defined using def macro, which, by the way, is a very interesting mechanism that I'm not going to touch on today. One can easily imagine a macro that does the same thing, but inserts IEX pry between each pair of code lines of the function. So you could create a def debuggable, for example, macro for that, but you would have to recompile a module for each function that you'd like to debug, so it would be no better than IEX break for most cases. I started thinking of how I could create a module that I can use and automatically make all functions debuggable like that. And the mere idea of having IEX pry all over the place might seem dumb, but later we'll show how to build on it to create a more practical mechanism. So the question is then, since def is a macro in kernel, can we somehow override this? So a module we create has a different definition of def itself. And the answer is yes, and quite easily so. Inside the code, we must code the original implementation of def with expr containing the body of function then, that can now be manipulated. So we will have some kind of ASD there. And outside the code expression, we can do whatever we'd like to do at the moment the function is defined. So when we define this function using our custom def macro, we will actually print some kind of diagnostic log. So that's just an example, and how can we use it for more practical purposes? We can, for instance, overwrite def to tamper with every function that we implement inside the module. For whatever purposes, maybe logging the moment the function is defined, like here. Or if we put this inspect thing here, we can log every time this function is called. Or do something totally different for debugging purposes, etc. And in a moment, we'll do this to tamper with the function to insert the price statements. So for demonstration purposes, I wanted to show that we are able to put an output message at the stage of defining the function, which is which gets logged here. And as you can see, that expr contains the function's AST. So we printed the expr here, and it's got the do argument, which contains the function as AST. As you can see, it was this tuple, and we have this tuple right here, represented as an AST. You can alter it so that, for instance, every function you create in your module contains a logger call at the beginning. And for easier usage in any of your modules, you could create a using macro, so you can plug it in with the use keyword and have it overridden like this. There is also a conceptually similar thing called safe override, which is similar but safer, and it's also meant to make us able to override macros and functions, and it's been proposed by QQWI at this GIST. It uses def overridable to make us able to call kernel special form super to call the original method in function instead of doing this. So instead of this code, we just call super. And when it comes to creating macros that conceptually just tamper with existing code to insert something here and there, I generally tend to use the 8 of code expressions that allow me to compare an example input with desired output, and then just transform ASTs with standard list manipulation techniques. So here's an example of a function that I would like to transform into having IEX.pry between each pair of its lines, as well as keep returning a value in the original way it was created. So the before variant looks like this. This is the function, and this is its AST. with two expressions inside the function body. And the after looks like this. So here's the function, and here's the result AST. And these are the original lines of code from the function's body. Now these are the new IEX.pry calls that we inserted here. And this is something I have to do in order to assign the last expression in this function to a variable that I can then conveniently return at the end of the function. So this is a simplified implementation of the new def variant, which creates a new AST, inserting new items in the middle, as well as assigning the original return value to a new variable and then returning its value after calling pry beforehand. So those manipulations we do here are actually just changing the AST of this function to contain these additional elements in addition to the original ones. There are some things to keep in mind. In each inserted IEX.pry call, we make the compiler pretend that it's actually in the same line as the following statement. So that statement is highlighted in IEX when you hit the breakpoint. So in the AST nodes metadata, you have the line thing, and line is taken from one of the lines in the original AST. And what's the precise pry helpers maybe pry thing? It's something I'll show in a moment. It's as if you called IEX.pry, but with a small condition. It's about the ability to both resume execution and navigate to the next line, because in our custom breakpoint definition method, IEX's continue helper in fact takes execution to the next line, which is not compatible with its original meaning to resume the execution. So it should still be able to both resume and step over lines of code. So let's create a next helper that goes to the next line, in this case implementing it as identical to continue, and a resume helper that does what continue would do originally. And for this we will use ETS to set something akin to a global flag that the IEX pry in our precise variant is now functioning. So in this implementation, when the module is mixed in using use, we create a pry macro that sets a flag in ETS that precise pry is running. Actually, for for production usage, not production, but for a final version of this debugger, it's not enough, because you could hit this multiple times in different processes, so you would kind of have to identify where you are and where you do have this flag enabled and where you don't. But on a conceptual level, it just means that we are in the precise pry enabled mode, and the breakpoint statements in our custom scheme are executed. So as I said, next works identically as continue in the original meaning. Resume calls continue if the ATS flag is set. Now, and the maybe pry macro, only called privately, looks up the precise pry flag in ETS, and then if it's set, so a breakpoint is currently activated and we're inside this, it calls IEX.pry, and otherwise it's just continuous execution. And then, as you can see, you can navigate through your code with the next helper. So if you use this pry macro that we created and then the next helper, it goes through particular lines of code in the module that has the use precise pry directive, and correctly returns functions values as defined in the code itself. So you call the pry macro here, and you are here, and then after next you are here, and then after another next you are here, and then you have the return value of this function. So I can see several obstacles that make this approach require much more thought to be fully practical, which was mostly due to Elixir's own macro-based nature. For instance, as we said, many language features are defined using macros, and we were overriding the def macro, which looks pretty crazy in itself, and applying the AST modification globally to the entire app would require replacing the def module macro to kind of recursively replace def in every module. So we can also imagine a recursive analysis of all functions in a module for the existence of nested anonymous functions and other code blocks, but it still wouldn't really help much for the purpose of stepping in and out of a particular line of code, because it would rely on all functions in question being decorated using our macros. So we might be able to overcome this with the break macro somehow, but it would require quite a lot of thought to do this in a practical way. So in general, I believe that while it wasn't the purpose originally, augmenting IEX with the ability to navigate in the code would be an awesome addition that would greatly boost developers' productivity. And moreover, there is still an important issue stemming from how macro expansion works. Well, if an evaluated line of code has an origin in a custom macro, you never get to see it in the stack trace or get there using IEX.pry. And the current place you're in at the time was where macro expansion was started, just as I presented in the peak implementation. But when I think that def itself is defined as a macro, then I'm wondering if there's maybe a better way to manage it. I don't know yet. Maybe I would have to look a bit deeper into the internals of the language, but it might be possible. So overall, with my presentation, more than anything else, I wanted to show how a tinkering attitude and willingness to experiment can help you circumvent the shortcomings of your existing toolset. Elixir and Erlang's got good tools that can cover your needs in both the low-level code debugging and monitoring the beam in production. But you can make them even better suited to your needs yourself in just a few minutes. And this is again an area where we can use Elixir's metaprogramming capabilities to adjust our toolset to our needs, while remembering that with great power comes great responsibility, and an overt indulgence in macro usage can make code hard to debug, even if we try to make it easier to do so. Though there's still definitely room for improvement in the compiler and related toolset with regard to knowing where you are in the code. All right, so before we get to the Q&A, thank you very much for listening. Here are some links to some resources where you can find me, as well as a companion repository that's not, it's not finished yet. It's as of today, it's empty, but just a few days after the conference, I'm going to insert some snippets of code in here, or even create a library that's gonna contain some of the tools I was talking about. So thank you very much.
Thank you. Do you have any questions? I have one. So, like you said at the beginning that like we have more options than like doing IoInspect. So how much time do you think you can actually save using more sophisticated tools?
Well, the time you save, I guess, is not on doing the particular steps in this, but the time you save is going to be about the having to or not having to switch between the tools that you have available to debug stuff. But because right now with tools that I've got available, I often find myself switching between this and that to do different kinds of debugging steps. And I guess my goal is to have one tool that's going to cover more of my needs than the ones I already know. So I guess that's the main thing.
Hey, you mentioned that to use that tool, we should tinker with the timeouts for like Cowboy X unit and Ecto. Do you have some way to maybe raise all the timeouts of Gen servers, like with Gen Stage, Flow, Broadway, like all of those are based on processes and their timeouts are everywhere?
To be honest, I haven't looked at this precisely. Every kind of those timeouts should be probably looked at separately, wherever it's configured. I would say it's often a good idea to have just one place to configure all the timeouts in your application as a kind of single point of truth for those timeouts. So at least in the dev env, it should be able, there should be a possibility to kind of suppress all the timeouts in bulk if you configure it well.
Okay, thanks.
So first of all, I would also love this tool or library to be there. So please do publish it when you can. And my question is, so while you don't have this yet working, so what is usually your favorite way of debugging? So which ways that you describe you are using usually?
Well, it depends on the project because in some projects it's really not a problem to insert the breakpoint programmatically as a line of code, and moving it around is not a problem. So in the current toolset that I have, it's probably easiest just to move it somewhere else. But some different projects that I have, having inherited them from an environment that had like 200 files be recompiled every time I make a single change in a file because of the dependency hell, then I just can't afford to do that. So I resort to whatever technique I have available to reduce the need to recompile stuff actually. And sometimes when I really need to interact with the particular execution context, then pry is really the only thing that I find convenient, because the entire ability to see the current binding, the current functions, variables, and so on is just too important for me to not to use it.
Okay, thanks.
Thank you.
We have one from the app. Joel is asking, how customizable is the Erlang debugger? Do you think it is possible to enable evaluating Elixir expressions with that?
Well, I think it could be possible to do that because I mentioned a tool called RexBug, which is a wrapper around Redbug. These are tracing tools basically, and the only difference between RexBug and Redbug is that it's obviously packed into Elixir modules and takes Elixir syntax natively and then translates it to whatever is needed in Erlang. So maybe a tool that would do this automatically for us would be pretty much helpful.
Thanks. Any other questions? Okay, thank you so much, Michal.
Thank you.